cans total. Sounds delicious. I'm a little bit under the weather here, so excuse the sniffles. All right, 35. Hermione. Oh, that's cute. Lord of the Rings reference. Oh my gosh, Harry Potter reference. Hermione is saving soda cans to donate to Hogwarts recycling efforts. The table below shows the savings. After 20 weeks, how many cans will she have saved? Okay. There's our data. Let's take a look at it. So here's week 10, 11, 12, 13, 14. So we are interested in week number 20. So we need to know how many cans she saved at week 20. Well, we know that she's already saved 1,080 cans. So we need to figure out what the change was from 1080 to get here. So we know that every 1 week, she saves 120 cans. So if she can save 120 cans in 1 week, how many will she save in 6 weeks? Well, simple multiplication. 120 times 6, 0. 2, 1, 6, 720. So she'll save 720 additional cans over those 6 weeks. Add that 720 to that 1080, and that will give you the number of cans she saved in 20 weeks, which would be 1,800. All right. So for 36, let's take a look at it. 36. Create the graph that represents the following situation. Be sure to label your axes. Miss Holmes drove from school to home. Then she sat on the couch and watched TV for a little while. Then she decided to go to Chili's for dinner. And then she returned home. Cool. Sounds like Mrs. Holmes knows how to have a good time. So let's take a look at our independent variable and our dependent variable. So it seems that she's driving around. So distance is going to be one variable, and she drives over time. It's per unit time. And time is always an independent variable because time marches on. So we'll label time on our independent axis, our x-axis. And our dependent variable is the distance from her house. And so that's what this axis should be. I'll label it distance from house. So she started at school, then she drove home. So the distance from her house decreased all the way to 0 because she got home. Then she sat on the couch for a little while. Then she got hungry and went to Chili's. Get her some of those baby back ribs with barbecue sauce. Alright, let's say she had a really long dinner. Ooh, real long, yep. Miss Holmes made it a long night at Chili's. Alright, then she decided to go home. And there she is. She's back at home. We'll extend that axis here. This was just for artistic effort. It doesn't have to look like that. She drove home, napped, went to Chili's, ate, went back home. That could be what your graph might look like. Okay, let's take a look at number 37 and 38. I'll move that to the next page here. Mrs. Vasey has been chosen to race in the teacher versus student track meet. Oh no! The following table shows her distance, meters, from the starting line every 15 seconds. Wow, well, let's see how she does. Uh-oh, something happened to her right here. 55, 55. Okay, so she's going at a little clip here. Pretty good clip. What are the independent and dependent variables? Oh, looks like we have time here. We know that time is always independent. So the distance she has run depends on meters. Or I'm sorry, the distance, the number of meters she's run, depends on the time. What's doing the depending? The number of meters run. So the dependent variable is number of meters. Depends on what? How long she's been running. So her independent variable is time. What was Miss Vesey doing between 60 and 75 seconds? Well, the number of meters run was 55 here, and then it was still 55 here. So she either, well, we know she didn't collapse because she continued to run. She was probably stopped for whatever reason. Maybe she was tying her shoes. Yeah, sure, that's a good explanation. The point is that her distance, the number of meters that she ran, did not change between 60 and 75 seconds. Using the milk consumption graph to the right, between what two time periods is rate changing the most? Okay, well, but for these are all, looks like these are all broken up into little 15-minute intervals. So between that interval, it looks like between 400 to 300. So 100 gallons was drank there, or I'm sorry, 100 cartons. Between that period, it looks like 50 were drank, 0 were drank here. Looks like another 50. Looks like 0 were drank from there. From here to here, it looks like another 100. Then from here to here, not quite 100, maybe like 90 gallons. And then from here to here, 0. Okay, so between what two time periods was her rate changing the most? It looks like there's 100 and there's 100. So between 11:30 a.m. to 11:45. And then from 12:45 to 1. When was it changing the least? Well, at all those 0 intervals. So between noon to noon 15. And from 1:15 to 1:30, the end of lunchtime. Okay, ooh, some fun tiles. Oh, I love tiles. This is going to be so much fun. All right, Vanessa oh wow, so Vanessa's gone from moving boxes to building tiles with triangular shapes. So Vanessa decided to make a mosaic out of tiles. She started with one tile in the center, term 0. That's term 0. So then every single term 1, term 2, term 3. She decided to follow a pattern by adding 3 more tiles, so her change is 3, to the mosaic. What's the pattern rule? Okay, well, she started out with 1 tile, and then she adds 3 tiles every n term. So 3n. That would equal number of tiles. Okay, great. And let's see if that's true. So let's say at term 3, so when n equals 3, she has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 times 3 would be 9, plus 1 would be 10. So yep, this is the pattern rule for number 40.